Hey everyone, welcome back to my channel. If you're new here, don't forget to like, subscribe and hit that bell button so you never miss fresh content. Today we are diving into my Python implementation for the Day 13 challenge from this year's Advent of Code. If you're not familiar with Advent of Code, check out my video about Day 1. I explain it there. Let's jump straight into the problem description. This challenge involves claw machines at a tropical island resort arcade. You control them with two buttons, A and B. Each button moves the claw in a specific direction and costs a different number of tokens to press. The goal is to align the claw perfectly with price position by figuring out the right combination of button presses while spending the fewest tokens possible. Some prizes are winnable while others aren't, and part of the puzzle is figuring out how to maximize the prizes you can win. For example, in one machine pressing button A 80 times, a button B 40 times, the claw aligns perfectly with the prize, costing 280 tokens. But not all machines are solvable, so we need a strategy to compute this efficiently. These are the example inputs. We have three lines for in blocks. Each block represents one claw machine. The first two lines represent the buttons and the positions that will be changed. So button A increases the X value by 94 and Y value by 34, and the price is at the position 8400 and at the x-axis and 5400 on the y-axis. In the part 2 of the challenge, things get a bit trickier. The input for the button movement stays the same, but the price positions shift along the x and y axis by some constant value. That means we just need to recompute the alignments of the new price locations while sticking to the same cost minimization strategy. So we will add this number to the x and y positions of every price and recompute the cost to get the price. Basically, we do everything the same, but only increase the price position values. At first, I need to parse the data. So we have the blocks of 3 lines each. The first 2 lines are the button informations, button A and button B with corresponding X and Y axis value changes. And how I accomplish this, I split the data into lines, append a final line that I will use later to detect if the block ends, because the last block actually doesn't have a new line like here in between. So to detect if the block ends, I've just put a blank line at the end. I also prepared empty list for the machines that we will parse. So one block is one machine. So we enumerate the data, we get the line, and we get the index of this line. If the line is a blank line, we want to process the 3 previous lines. So we go over this line, this line, this line. We get to this point and I fetch the 3 previous lines and save it to a variable called machine. I create one dictionary that represents all the fields. So A stands for the input A, so button A. It has dictionary as argument. I will store there the X and Y values. The same for B and for P as a price. So I iterate over the first 2 elements, excluding the last element, which is price. And I iterate over the buttons, basically. I get the index and the button, right? The button line. I split the button line at the colon character, so I have two elements. One is this one and the other is the values. Then I fetch the first element, split it at the blank line, so here, and get the last element from it and strip it. So I remove the spaces. In this way I get the letter of the button. It's called button ID in my case. Next I iterate over the button data -1, so the last element from the previous split at the column place. So I get this element and split it at the comma sign, so I have two elements again for x and y, and I split each element at the plus sign to get the letter and the integer value, and save it to the dictionary I instantiated before. So this is for the part with buttons. Then we have this basically the same procedure for the price, but in this case I split at the equals sign and not at the plus sign. At the end I attach the machine dictionary to the machines list, and that's it for the for loop. So every single block will be transformed in the same way to a dictionary and stored in the list for later. For the part 2 and part 1 I use the same method, get press count. It takes in a machine as a dictionary. So this is the same object that is stored in the machines list. I fetch the A dictionary, B dictionary, and P dictionary from the machine to use it later. To solve this problem, I approach it from a mathematical angle. So the problem looks very much like a linear system. So I tried to solve it with a linear system, and it worked. So it works also with very big numbers. So this comes in part 2. I don't need to brute force every combination of button A and button B presses. So I compute the value for X, which is the number, the count of the presses for button A, and with this value I compute the value for Y, and Y is the press count for button B. With these values I multiply the X values from the dictionaries and Y values from the dictionaries to get the sum of movements on each axis, and then sum it up here in this if statement to check if the price is at the same point where I sum these variables together. If it is the case, I return the press count for A and press count for B, and if it's not true, then I return a non-value to indicate invalid values. Next, I implemented a getCost function that takes in a press count for A button and press count for B button, and if it is a non-value in any of these press arguments, then I return a -1 to indicate invalid value, and if the values are not none, then I multiply 3 with A press argument and add B press argument to it, because B press is multiplied with 1, so I can directly add it to the previously computed multiplication. For the part 1, I go over all machines, plug it in the get press count, and the result from get press count is passed to get cost. So I have an array of cost per machine. After it, I filter out invalid values. I do it with filter and check if the x is greater than -1 for each cost and convert it back to a list. At the end, I print the sum of all costs, and that's the final answer for part 1. For the part 2, I previously iterate over all machines and increase the price x and y value by a constant increase that is defined in the part 2 description. Later I do exactly the same thing like in the part 1. So I iterate over machines, get each machine, get I call the get press count, it returns a value which is consumed by get cost, and I have a list with cost per machine. I filter out all the invalid values and sum up the costs, and this is the final answer for part 2. If I run it, it's pretty quick, so it's really efficient with big numbers. I don't need to brute force anything. It is very fast, so there is no need to implement it in Rust. To visualize you how I approach this from mathematical point of view, I took the first example from the test dataset and created a linear system with two equations. So basically, first equation returns the value of the price x, and the second returns the value of the price y. So at first I need to take the first equation and solve it for y. So I take the 94x and subtract it on both sides. Then I have 22y, 8400 minus 94x. Then I need to divide it by 22 on both sides to have only y on the left side. So I divide 22y by 22, and 22y divided by 22 is 1, so it's 1y. And I divide the other side with 22 as well. In the second step, I take this value for y and put it in the second equation for the y. So I substitute y with this thing right here and then calculate everything. So I need to take the 34x plus 67 times the thing in here is equal to 5400. Then I need to take the value without any variables, without x. I need to take it over to the right side, so I subtract it on the both sides. So I have only x's on the left side and only values on the right side. Then I simplified to fractions on both sides. So it's minus this thing times x and minus this thing. So then I need to divide it by this number, by negative this number. So I have only x on this side. I can divide this value by this value right here by flipping it over and multiplying it right here. And if I calculate it, everything together, if I multiply it, then the final answer is 80 for x. So it means that we need to push the A button 80 times. And if we take this 80 and put it back into this equation we computed for the y variable, we get an answer of 40 for B button, so B button needs to be pressed 40 times. These are exactly the same values that are provided in the example for the first entry in the test dataset. So that's how I tackled the day 13 challenge of Advent of Code in Python. If you're also working through Advent of Code, let me know in the comments how you approach this challenge. Did you find a way to optimize your solution further? I'd love to read your comments. For now, thanks for watching. Until next time.